All right, let's talk about ASCII and Unicode, which is the other real important thing about all modern languages. In the early days, languages like C just used 1 byte per character, and they only covered English. But now we want to cover international languages, so 1 byte is not enough to encode a character anymore. So I can use Python. In Python 2, you could do this. You could just have byte 41, which you represent as \x41. That's hexadecimal 41, 42, and FF, single bytes. And those would be letters, A, B, and the FF is not a printable character because ASCII only uses the first 127 possible values of a byte, but you could store a byte that did not code to an ASCII character. And that's true of Python 2 and C, and it's actually kind of stupid and weird that you would store a character in a data form that is intended for something else and that can contain invalid characters. And you don't do that anymore in modern languages like Python 3. So let me get my Python 3 going in interactive mode, which is an easy way to do simple scripts. And let's take a look at this stuff. I'm going to resize this to make it easier. All right, so here I define the same thing in Python 3. I define a string with quotes, and if you use the \x, that means literal hexadecimal numbers. So I define something 41, 42, and FF. And when I print it, it prints A and B. When you just put the name of a variable without saying anything, in the interactive mode here, it will print. But the last thing turns into a weird character, a Y with an umlaut. So you might wonder why, and by using A bracket 0, A bracket 1, and A bracket 2, I can print those out. And you'll see the first two turned into the expected ASCII value. ASCII of 41 is capital A and ASCII 42 is capital B. But this FF turned into that strange foreign character. And, all right, you can see the bytes this way. If you do B is A encode, you can then print out the bytes one by one. And you can see the first character here is indeed hexadecimal 41. When you're putting it in a string, you use \x to refer to literal hexadecimals, but you can also use a 0x in front of it, and that's the way this printout is. 42 is here, but the third character, when I put in FF, it turned into a 2-byte string C3BF. So that is Unicode. And that is the madness of Unicode. But here's the reason why it works. The point of Unicode is to come up with a system that can encode all the modern languages, all the modernly commercially important languages, Chinese, Japanese, Arabic, Russian, everything, and yet still remain backward compatible for English to ASCII. So the number of bytes it takes to encode a character now can go from 1 to 4. Single bytes are just the old ASCII code, always starting with 0. So the ASCII is compatible. A single byte still codes to a single byte of ASCII. Then there are characters that encode with 2 bytes that have to start with this pattern, and 3 bytes and 4 bytes. So this is very much like the IPv4 address space with classes A, B, C, and D. You have, and the total here is there are 2 million what's called code points in Python. There you can encode up to 2 million in Unicode. In Unicode, you can encode up to 2 million different characters, and those are now internationally recognized. So you represent them not with \x, but with \u. So let's take a look at some examples of Unicode encoding. And all right, let me scroll back to the start of this. Okay, so first I start with \x41. That's the old ASCII encoding, hexadecimal 41, that's a capital A. Now I can do Unicode 41, and it will refuse to accept it. You're only allowed to put 4 bytes in your Unicode. So you can't put in 1 byte, 2, or 3. You have to fill in Python, you have to fill in all the missing zeros. That is another way to write a capital A in Unicode. And you can also take the byte here and encode it, and that'll turn it into a byte object which starts with a B. So that is the joy of Unicode. And here you can see what happened to the FF, that funny character that turned into something else. When I try to do, I can make that FF and it's a Y. If I try to make it Unicode, it won't let me do it unless I make it 4 bytes long. But if you make the Unicode thing that is ending in FF, it's the Y, and it's actually C3BF. So it turns this, which is an illegal binary sequence for Unicode, into the corresponding Unicode character, which is 2 bytes C3BF. So anyway, there's a couple of flags to find here where you learn to encode some strange characters like a sigma and a hamburger. You'll just have to Google to find those Unicode points. But that gets you a little bit used to the modern world of Unicode, which is what all modern programming languages use. So let me stop this one.